posters have in common? They all depict disasters. As seen in various disaster movies, nature is extremely powerful. There are many types of natural disasters, but today we will be examining natural phenomena created by forces below the crust: volcanic eruptions and earthquakes. The Earth's crust is located below the ground on which we live. Deeper still within the Earth, awesome powers are at work. Just think, the ground on which we live is alive and moving. And the forces that move the ground we live on are the forces behind volcanoes and earthquakes. In what we call volcanic activity, magma created deep inside the earth rises up through cracks or weak points in the crust, erupting out of the earth's surface. In a volcanic eruption, the first thing to be released is gas. Most of this volcanic gas is water vapor, but there are also smaller amounts of other gases, such as carbon dioxide and sulfur dioxide. This gas is followed by solids that have been broken up by volcanic gas or the impact of the volcanic eruption. This solid matter is called pyroclastic material. Pyroclastic material is classified by particle size, from small to larger. These categories are volcanic ash, volcanic dust, lapilli, and volcanic bombs and blocks. The most important of these materials is volcanic ash. Volcanic ash particles are extremely small and remain suspended in the atmosphere for a long time, forming a layer. This layer reflects sunlight back into space, lowering air temperatures. In the past, large volcanic explosions have caused many ice ages. Volcanic ash also poses a serious threat to aircraft. In 2018, a volcano on Bali in Indonesia erupted, and the resulting volcanic ash caused the Bali airport to be temporarily shut down. What is the hot, red fluid that comes out of an erupting volcano called? Is it called lava or magma? The correct answer is lava. Many people use the terms lava and magma interchangeably, but there is actually a clear distinction. Molten rock that is still underground is called magma, and the same fluid is called lava when all the volcanic gas has escaped and it is flowing on the surface after a volcanic eruption. What happens when this hot lava cools down? If the lava spreads across a wide area, it hardens and small amounts turn into rock. This volcanic rock is classified as basalt, andesite, or rhyolite, depending on its silicon dioxide content. The basaltic lava of Mauna Loa in Hawaii has a low gas content and flows quietly. Basaltic lava can only reach the surface if there is a crack in the Earth's crust. This type of lava has a silicon dioxide content of 52% or less, making it highly fluid with a low viscosity. Fluidity is a measure of how well a material flows, and viscosity is a measure of how sticky it is. They are opposites of one another. Basaltic lava has a high temperature and creates broad lava plateaus and shield volcanoes with gentle slopes. Rhyolitic lava, on the other hand, has a high gas content and low temperature. As a result, it erupts with much more force than basaltic lava. Rhyolitic lava has a silicon dioxide content of 63% or higher, giving it a low fluidity and high viscosity. This type of lava creates lava dome volcanoes like Mount Pektu in Korea. The characteristics of andesitic lava volcanoes, like Mount Fuji in Japan, are somewhere between basaltic and rhyolitic lava volcanoes. Earthquakes are another disaster caused by volcanic or fault activity. In an earthquake, the energy built up inside the earth is released in all directions in the form of waves, causing the ground to shake. The point inside the earth where the earthquake has occurred is called the focus, while the point on the surface directly above the focus is called the epicenter. Earthquakes are classified according to the depth at which they occur. An earthquake whose focus is less than 100 kilometers deep is called a shallow focus earthquake, and an earthquake with a focus deeper than 100 kilometers is called a deep focus earthquake. The waves caused by an earthquake are called seismic waves. There are three types of seismic waves: P wave, S wave, and L wave. The fastest of which are P waves, followed by S waves and L waves. The amplitude and the amount of damage caused by earthquake are expressed in the opposite order. L waves are the most destructive, followed by S waves and P waves. Naturally, stronger amplitude results in more damage. Given the same underground conditions, amplitude and damage increase together. There has just been an earthquake. The red house is closer to the epicenter than the blue house. As a result, more windows in the red house were shattered. In other words, the seismic intensity of the earthquake was greater at the red house. Seismic intensity is a term used to describe the strength of earthquake vibrations and how much damage they cause. However, the amount of energy released by the earthquake is the same at both the blue and the red house. Magnitude is a numerical value that represents the amount of energy released at the focus of the earthquake. There is another type of disaster we should mention at this point. Many of us remember the Japanese earthquake of 2011, which demonstrated the power of seismic sea waves. These seismic sea waves are caused by sudden changes in the crust due to undersea earthquakes or volcanic eruptions. These seismic sea waves are also called tsunamis. When we're at the beach, it's easy to see that the water gets shallower as it gets closer to the shore. Likewise, the depth of seawater decreases as a seismic sea wave approaches the shore. As the wave approaches, it moves slower, but the height of the wave increases. That is why, as we see in many disaster movies, seismic sea waves grow taller as they approach the shore. Where do these powerful underground forces come from? As we've already mentioned, the ground we stand on is always moving. Below the crust on which we live is the Earth's mantle, the 100-kilometer thick layer of solid rock, including the crust and part of the upper crust, is called the lithosphere. The upper mantle that lies beneath the lithosphere is called the asthenosphere. The asthenosphere is also solid, but the rock here is softer due to high pressure and high temperatures. Differences in temperature between the inner and outer parts of the asthenosphere allow convection to occur. In some ways, the consistency of the asthenosphere can be compared to that of butter. Even though it is a solid, it can be pressed and molded. Convection in the asthenosphere forms the foundation of plate tectonics. The Earth has 10 small and large plates, which include the North American plate, the Pacific plate, the Eurasian plate, and the Nazca plate. The Pacific Plate is an example of an oceanic plate, and the Eurasian Plate is an example of a continental plate. The relative motion of these plates causes crustal movements, such as earthquakes and volcanic eruptions, at plate boundaries. 90% of Earth's earthquakes and 75% of its volcanic activity occurs in what is called the Ring of Fire. There are three types of plate boundaries: transform boundaries, divergent boundaries, and convergent boundaries. In a transform boundary, two plates move horizontally to one another. In a divergent boundary, the plates move away from each other, while in a convergent boundary, the plates collide. Divergent boundaries are the result of rising convection currents in the mantle and are characterized by volcanic activity and shallow focus earthquakes that occur at relatively shallow points. Divergent boundaries also create V-shaped rift valleys and undersea mountain ranges. Iceland is an example of an undersea mountain range that has been pushed above the ocean surface. Transform boundaries, where plates slide against one another, are characterized by shallow focus earthquakes, but do not have any volcanic activity. Without volcanic activity, plates are neither created nor destroyed. This is why this type of boundary is also called a conservative boundary. An example of this is the San Andreas Fault. Lastly, in convergent boundaries, which are created by descending convection currents in the mantle, plates can collide with each other, or a more dense plate can move beneath a less dense plate. In this type of action called subduction, the denser plate melts back into the mantle. If continental plates with similar densities collide, they can create large folded mountain ranges. If an oceanic plate and a continental plate with different densities meet, the dense oceanic plate may become subducted beneath the less dense continental plate, creating trenches, volcanic islands, and folded mountains. Unlike in other plate boundaries, both deep and shallow focus earthquakes, as well as reverse faults, can be observed. As we have seen, there are many complex processes at work behind earthquakes and volcanic eruptions. Disasters can occur at any time, anywhere in the world. We should all be aware of how to react to natural disasters